Understanding the difference between static and kinetic friction in physics. Friction is the force that opposes motion between two surfaces in contact. Let's explore the two types of friction. Let's start by understanding static friction and when it acts. Static friction is the force that prevents an object from starting to move when a force is applied to it. What's interesting is that static friction adjusts itself to match the applied force, up to a maximum limit. The mathematical relationship is that static friction is less than or equal to μs times the normal force. Here we see a stationary object with an applied force and static friction acting in the opposite direction, keeping it at rest. Now let's understand the maximum value of static friction before motion begins. The maximum static friction equals μs, the coefficient of static friction, times the normal force. Once the applied force exceeds this maximum static friction, the object will start to move. This graph shows how static friction increases linearly with applied force until it reaches its maximum value, where motion begins. Once motion starts, we encounter a different type of friction, called kinetic friction. Kinetic friction is the force that opposes the motion of an object that is already sliding. Unlike static friction, kinetic friction has a constant magnitude that doesn't change with the applied force. The formula is Fk equals μk times the normal force, where μk is the coefficient of kinetic friction. Here's a moving object with applied force greater than kinetic friction, causing it to slide across the surface. The most important difference between these two types of friction is their magnitude. The coefficient of static friction is always greater than the coefficient of kinetic friction for the same surfaces. We can express this as μs is greater than μk. This means maximum static friction is greater than kinetic friction. This visualization shows that static friction is larger, making it harder to start motion than to keep an object moving. Let's look at a practical example with actual numbers to see how this works. Consider a 10-kilogram box on a horizontal surface with a normal force of 98 newtons. Let's say the coefficient of static friction is 0.6 and kinetic friction is 0.4. Maximum static friction equals 0.6 times 98, which is 58.8 newtons. Kinetic friction equals 0.4 times 98, which is 39.2 newtons. This means you need 58.8 newtons to start the box moving, but only 39.2 newtons to keep it moving once it starts. Let's examine what happens at the exact moment motion begins. This graph shows the transition from static to kinetic friction. Notice the sudden drop when motion begins at the transition point. Several factors influence the magnitude of both types of friction. The roughness of the surfaces in contact greatly affects friction. Rougher surfaces have higher coefficients. The normal force, which depends on the object's weight, directly affects friction magnitude. Different material combinations have different friction coefficients. For example, rubber on concrete has higher friction than ice on metal. Rough surfaces create more friction than smooth surfaces due to increased contact points and interlocking. Let's summarize the key differences between static and kinetic friction. Static friction prevents objects from starting to move and varies to match applied force up to a maximum. Kinetic friction opposes ongoing motion and has a constant magnitude regardless of speed. The coefficient of static friction is always greater than kinetic for the same surfaces. Remember, static friction acts when at rest and is variable, while kinetic friction acts during motion and is constant.